Section 4.3 puts us to a place where we have to understand that exponential and logarithmic functions are inverses of each other. There's a direct relationship between these two things. So for the exponentials, you can have any base other than 1, or you can also incorporate the base of e. And when you change this into logarithmic, your big base b here becomes baby base b here. And then you have y, and then x is your exponent that is now over on this other side. So the answer to logarithmic equations are exponents, okay? Now, if you have a baby base of e, or a big base rather of e, it's understood to be here. It's not written. So you're going to be changing these from logarithmic into exponential and exponential into logarithmic. So for this section, that is the key components right there that you're going to need. So these first few just want you to change it. So if we take log base y of b, don't get the b's confused as far as base is concerned, is equal to s. So your baby base y here will become big base y when I change it into the exponential. The s that's over here furthest away will now be up close and personal to my base, because that's my exponent, and then that's equal to b. So for this one, I have a log that has nothing written, so this is understood very clearly to be 10, okay? So anytime there is no base included, it is going to be a base of 10. So again, we take that base of 10 in red, and it now becomes your big base 10. Q is your exponent, so it goes with the 10, and that will be equal to b again. All right, so that's going from logarithmic to exponential. So now we're going to go from exponential. I have 7 raised to the power of a is equal to z. So we're going to be changing this into logarithms. Now, because my base is a number, then I'm going to use log instead of ln. So the big base 7 that's here will become the little base 7 that is a subscript. All right, your exponent, remember, is on the other side. So that leaves z to be what we are taking the log of. All right, this next one, we have again a base of a number, 10, so log, and we don't write a base of 10. It's not wrong if you do, and they shouldn't count it wrong online, but that log without anything as a base is expected to be the the value of 10. So then we have our exponent, of course, is always furthest away on that side by itself, and then we're taking the log of w. Now, one that I had not written that I'm going to go back and do is if you have e to the 7th is equal to m. All right, if we change that, we're not going to use an log, we're going to use an ln. And the reason I do that is because of the base of e. That automatically puts me into ln, which stands for natural logarithm. We'll talk more about these in just a little bit. ln stands for natural logarithm. So that baby base of e is there, but we do not write it. Anytime you see ln, your base is an e. All right, so our exponent is always furthest away, and then we are taking the natural log of m is equal to 7. So going back and forth with these is something that you need to get very comfortable with. So now we move into the solving part of these. So to do this, all we're going to do is change these into exponential and then finish from there. So as I look at this first one, I have a baby base of 6 here. And if I'm changing this into exponential, then that baby base becomes the big base. Then 5, of course, is my exponent, and that's what p is equal to. You can type that number in. You do not have to calculate it, but if you do want to calculate it, it is 7,776, and that's what p would be equal to. So this other one over here to the right, again, we have a baby base of 6. These are randomly generated, so I didn't do that on purpose. So we will now have a big base of 6. I raised that to the -8th power, and that's what B is going to be equal to. So my B is going to be equal to a hefty decimal, or you can do 1/6 to the 8th power. So if you use 6 to the 8th power, you will have 1/1679616. All right, so this one a little different. My base is a variable. So this subscript here is my variable x. So this will be x, and my exponent is 2, and then 16. So x is equal to 4. Square root of 16 is the number 4. The next set we look at is just giving you log base something of something, and it wants you to solve it. So for these, if it's not equal to anything, you're just going to set it equal to a variable of your choosing, and it does not matter which one you use. We tend to default to x's, so that's what I'm going to set these equal to. So again, with these, what you're going to do is change these into exponential form, every single one of these. So for the first one, we have 2, and we're going to raise that to the x power, and that's going to be equal to 1/32. So this is an example that when you look at it, maybe you don't automatically notice, but you can write 32 as a base of 2. So this gives me 1/2 to the 5th power. So that's 2 to the x is equal to 2 to the -5th. So at that point, I know then that my answer is x equals -5. So for the next one, we have the baby base of 5 raised to the x power, and then that's equal to what's in parentheses, so that's 5 to the 1/3 power. So then x has to be equal to 1/3. Since the bases match, then the exponents have to match. For the next one, we have a base of 10 that's understood to be there. And then this is x, is my exponent, and then I have 100,000, which can be written as 10 to the 5th power, so x is equal to 5. And then the last one of these, we have the base of 10 that's understood, raised to the x power. This is 1/10,000, which means that I have 1/10 to the 4th power, and then I pull that to the top by changing my exponent into a -4. So that means that x would have to be equal to -4. Be sure that you show these steps when you do these problems. So these are another set that are not equal to anything, so I'm going to go through and set each one equal to x, and then we will go through and solve each of these. Some of these start in logarithmic form, some start in exponential form. So for the first one, I have a logarithmic that of course is natural log because the base is an e that's understood. I'll put it in red. It's understood to be a little baby base here, so that baby base becomes big base. I raise it to the x power, and then that's equal to what's in parentheses, e to the -7. So this indicates that x would be equal to -7. So those are logarithmic to exponential. I'm going to actually come down to the bottom and do this last one because it is exactly the same way. So this is a baby base of e that becomes big base e. It is raised to the exponent of x, and that's equal to 1/e to the 5th, but you bring that up, so you have e to the x is equal to e to the -5, so that's x is equal to -5. So those two are like the ones that we did on the page before. Now these middle two are the ones that tend to confuse children, so I'm going to spend a few extra minutes on these, but you do start the exact same way. You're still having to start with the fact that you have an exponential, and now we are changing to logarithmic. So for whatever reason, this tends to be more complicated for kiddos. So as I'm looking at this first one, we have a base, big base of e. So that becomes baby base E. That is not written, so I'll put it in red. That's not actually there. Okay, so that takes care of this. The exponent here is what's on the other side of the equation. And then this x that's left has to go here. So because those two natural logs are the same, then what they are being taken off have to be the same. So the x and the 3 would have to be equivalent. So you have to show this work when you do these. All right, this one, this little e, the base of e becomes this little e that's understood to be there. The exponent up here goes to the other side of this expression, so natural log of the square root of 3, and then the x goes here. So the two things that I'm taking the natural log of have to be equivalent. X is equal to the square root of 3.